We're going to take a look at applying our ratio and proportion problems to scale. So in this particular examples, we're going to do similar figures and map scales. All right, so our first scenario, find the distance between Centerville and San Jose on a map with a scale of 1.9 centimeters to 8.3 kilometers if they are actually 5.7 kilometers apart. So again, let's start off just like we did the rate problems. We start off by stating what we know. We know we are comparing centimeters to kilometers. We know that we are comparing the map distance to the actual distance. We are also doing map scale is 1.9 centimeters to 8.3 kilometers. So we are given that, and the actual distance is 5.7 kilometers. Okay, what we need to know is that the map distance, or we need to know what is the map distance between Centerville and San Jose. So our definitions, scale is a ratio that compares two quantities with different units, and a proportion makes two ratios equivalent. So that's what we're going to be using. To quantify our symbols, we're going to let M represent the map distance between Centerville and San Jose. And again, you could use D for distance. It's up to you whatever symbol you want to use. All right, so the next step is to explain, set up, and solve the problem. So here we are comparing, we're setting up a ratio map distance to actual distance. So the map distance is 1.9 centimeters to 8.3 kilometers. And that is going to also equal some number of centimeters over 5.7 kilometers. So once we have that set up, now we can rewrite this and drop the labels so that we can just do the calculations. So we have 1.9 over 8.3 is equal to M over 5.7. Using cross multiplication theorem, we're going to cross products. 1.9 times 5.7 is equal to 8.3 times M. When we simplify, we get 10.83 is equal to 8.3 times some number. And again, through our definition of multiplication, some number times M is 10.83, which means that 10.83 divided by 8.3 is going to give us that number. And when you do that, you will get 1.3. So 1.3 is our missing value. And now our conclusion. Therefore, using a map scale of 1.9 centimeters to 8.3 kilometers, if the actual distance between Centerville and San Jose is 5.7 kilometers, then the map distance is about 1.3 centimeters. Okay, so that is our written explanation. And here is where you plug it in. Map distance to actual distance, 1.9 centimeters to 8.3 kilometers, and 1.3 centimeters to 5.7 kilometers. All right, so let's take a look at similar figures. Find the actual base and height of the figure represented by the scale drawing. So we have a rectangle with lengths of 24 centimeters and 14 centimeters, and our scale is 1 centimeter equals 3 meters. So on this one, go ahead and pause the video and see if you can figure out what you know. Go ahead and state what you know, then continue the video to see if your statement is correct. Okay, for stating what is known, you should have written down that the scale is 1 centimeter to 3 meters, that the scale drawing has a base of 24 centimeters, or length, however you want to say these, and the height or the width, if you want to call it that, 14 centimeter is that. All right, next, what is needed? Again, pause the video and state what is needed, and then continue. Okay, what is needed, you should have written down something to the effect of the actual base and height, and this is going to be in meters. All right, next part, definitions. What definitions do we need to know? Go ahead and write those down and then check to see if you're right. Okay, some definitions we need to know is scale is a ratio that compares two quantities with different units, because we are comparing centimeters to meters. And we are going to set up a proportion to make the two ratios equivalent. All right, so now that we have set that up, we want to quantify our symbols. Now this is actually going to be two problems because we want to find the actual base and the actual height. So we're going to let B represent the actual base, and we're going to let H represent the actual height. All right, set up, explain, and solve the problem. I'll give you a hint. It's actually two problems. So go ahead and see if you can set up and solve the problem, and then check to see if you were correct. All right, here is our explanation. First, I started off with the actual base. If you started off with solving the actual height, that's fine too. But the actual base, to set up the problem, our scale, and I went ahead and did drawing to actual, would be 1 centimeter to 3 meters. And we want to get the actual, so since we are given 24 centimeters for the base, we need to know what that is in meters. So 1 over 3 is equal to 24 over B. Okay, so carrying that over to this slide, we now drop the labels. We have 1 over 3 is 24 over B. We use our cross multiplication theorem to get 3 times 24 is equal to 1 times B. And 3 times 24 is 72. And since 1 times B is B, in this case we don't have to do any division. So we are down to what B is actually representing. So our base is 72. So now let's do the actual height. Again, setting up the problem the same way, drawing to actual, 1 centimeter to 3 meters, and 14 centimeters to the height in meters. So this is where H comes in. Again, drop the labels, do our cross multiplication. 3 times 14 is equal to 1 times H. 3 times 14 is 42, and 1 times H is H. So again, no division here needing to be done, so our height is 42. So, therefore, go ahead and draw your conclusion and then check to see if your conclusion is correct. And you should have had something like this. The actual base and height of the figure are 72 meters and 42 meters. So just a nice, easy one-sentence summary. All right, now it's your turn. I'd like you to do a complete, detailed write-up of this problem and bring it into class. So the drawing scale is 3 inches is to 10 feet. Find the base and height of the actual figure given the drawing. And you're given a base of 11 and 1/10 inches and a height of 5.7 inches. All right, again, try this out and bring it into class, and we'll do an edit and revision before your final draft is due. See you in class.